Okay, so we're going to go back and talk about what we were doing at the end of the period yesterday on secants in circles. So hopefully you're kind of getting the GeoGebra opened up, and I'm sure we'll wait till to get going on this part until everybody has GeoGebra. So if we pause the video until everybody's ready to go. All right, so we should be in GeoGebra right now. We're going to create a circle like we did yesterday and have been doing circles center through a point. There we go. There's my circle. And remember yesterday we drew a secant and that was a line. Okay, so the chords that we have been looking at were segments with endpoints on the circle, but a secant is a line. So I'm going to draw a line. I want to do a little better job though, and not getting what I want. And if you just, there we go. Okay, so there's a secant that I want right there. Then I'm going to draw another line here, and like that. So there's my two secants, and we played around with these a little bit right there. I'm going to move those points over there. There's my two secants. Here they intersect, 2 points, 2 points. All right. And I said, hey, what do you notice about these secants? And somebody said, well, they intersect outside the circle. So that, oh, okay, that's true. That's a great idea. So somebody saw that. I said, that's great. The question was asked, then, well, do they always intersect outside the circle? Well, let's take a look. So if we move this inside, yeah, it sure looks like it, huh? Right? But then if I move this point, I see that they actually could cross inside the circle, and they could actually cross on the circle. All right, so my secants, my two secants can cross, intersect outside the circle, inside the circle, or even on the circle. All right, those are the things that we noticed about the secants. Second thing we started talking about yesterday, somebody said something about, hey, I noticed that there were some triangles here. Oh, yeah. So let's look at that. So, again, pause this video at any time. I want to make sure that you're staying up with me. I want to make sure that you're kind of seeing what's going on. So don't be afraid to pause. Just tell Mr. Breeder, hey, can you hang on for a second? Can we pause it? All right, it's made for that, so make sure that you feel free and accident to pause it. So we should have two secants made here. We're going to go ahead and make these triangles. To do that, we need to go to the intersection tool down here, and we want to intersect this line here and this circle here, and the same thing with this line and this circle. Okay, so now we've got some points here, 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 and here. All right, and I'm going to go ahead and form those triangles by drawing a segment between those points. So I have to get this point right dead on there, else it isn't going to work. Okay, let's see if I did it right. Ah, it looks pretty good. Okay, so what I have here is two triangles. I have this triangle here, all right, and then I have this larger triangle out this way. So then if I take and outline those triangles, just the top one I'm going to do it using the polygon tool. All right, and the reason why I did that is so I could talk about them. So this is a smaller one which we have shaded, and then we have the larger one, all right. And those are the two triangles. So we think there's something special with those two triangles that the secants make. Well, what is it? What do we notice possibly about these two triangles? Well, they're not congruent. What was it that we talked a lot about with triangles in the last unit? We did this a lot. Hopefully you said similar. Okay, we're looking for similar. Because if these triangles are similar, which maybe they are, they kind of look like it. Let's check it out. But in order for triangles to be similar, we know what has to happen. Hopefully you said two angles. We have to have two angles that are equal, okay? Two sets of angles. So obviously, if we look at this smaller triangle up here that is shaded, we can see that this top angle right here is one of the angles. And in the larger triangle, if I outline that one, I can see that those two angles are shared. So we have one for sure equal angle. So if we look at the other angles here and here, we may say, well, I'm not sure that they really look like they're equal. But let's measure them anyway and see. So I'm going to go to the angle tool, and I'm going to measure these angles. So I'm going to start here, and I think this is the point I want. Go to here, and then go over to here and measure that angle. Alright, and let's see what I got. It looks like I got 87. So now I'm going to measure the same angle down here on the bottom. Alright, so I'm going to start at the top, go all the way down here to this point, and go all the way to this point. And it didn't work, so let me try it again. Oops. Move that 87 out here. I'm going to measure the angle again. So I need this point, and I need this point, and I need this point. There, I got it. And let me move that around. Okay, so I have 68. Alright, so obviously those two angles aren't the same. So now I'm starting to maybe doubt myself. Maybe these triangles aren't similar, but let's measure these other angles, okay? So we're going to measure this one here. And this one here. Let's see what we have. Oh, we have 87.4. And we have 68.97. So we can see that in actuality the angles are equal. It's just maybe not the ones that we thought. It's the ones that are kind of on the cross here. So this angle and this angle and this one and this one. Interesting. And we can dynamically move that around and check to see, hey, does that always hold true? And in actuality it does. So these two angles or two triangles are similar, kind of as we suspected. So what does this exactly mean? Well, let's look at this in our notes here for a little bit. I want to go to OneNote and draw this out. Now, you just kind of watch, and then we'll come back and look at it in our notes too. So you guys don't really need to get your notes out right now. We'll do that in a few minutes. But I just want to look at this problem here, kind of sketch some things on paper, or on the tablet in this case. Okay, so let's see, I'll draw this triangle here, draw this triangle here. So again, just to outline this, so here's a triangle here in green. It's similar to this triangle here. I'm not sure what color this is, maybe a brown. Alright, so triangle, let's see, RAL is similar to triangle. Now the R is okay, right? But the A corresponds with the O, so we're going to go like that. Alright? Because we have the shared angle here, and then this angle is congruent to this angle, and this angle is congruent to this angle. Alright. So since those triangles are similar, we can write proportions. So our proportion would be RA, right? That's this side up here, is proportional to what side in the other triangle? Well, that would have to be over on this side, because remember, they kind of flip. So then it would be over RO. equals. Now we'll pick RL in the small triangle over RC, because that's the side that it corresponds to in that triangle. So there we go. So now we have this proportion. Okay, RA, that's this side, all right, over the long side over here, RO, is equal to this side over the long side over here, RC. We're going to just cross multiply here. All right, so now we have RA times RC is equal to RL times RO. So now that makes a little bit more sense, because here we're talking about sides that are sort of on the same side or on that secant. So we'd have RA, which is on this secant, multiplied by RC, which is on the same secant, equal to RL times RO, which again are on the same secant. So this idea makes sense now. So I can see why the triangles may have been a little bit different in that case, and they were kind of flipped, because it turns out that it makes sense when we do the proportion and the cross multiply. All right. So I wanted to have you see that part with the secant. So we're getting two triangles there, similar. We noticed that. We noticed that they intersected. The other thing that somebody noticed was that there were some angles formed. There was an angle formed here, and that left us with a couple of arcs, intersected arcs that the secants actually form. So we wondered if there was a pattern. Maybe there's some sort of a pattern relating with those. The only way we can measure these arcs, though, on GeoGebra is by constructing angles, because we can't measure an arc measure in GeoGebra straight anyway. There's a little formula I have to put in, but there's a better way to do it, right, than just using this formula. So we're going to use that idea. Since this is the center, we can draw a central angle that would go from here, where this point is, to this one, and from here to that point. And now we would have a central angle, and we know that the central angle and the arc are the same measurement. So let's do the same thing on this side. Hopefully I'm hitting the point right. It looks like I am. So now we have a central angle here and a central angle here, which is equal to those arcs. So all I have to do to get those arc measures is just measure the angle. The central angle, that is. So let's do that. Oops, measured the wrong way. Alright, so let's see. I'm going to go get this one while I got the tool activated here. Okay, so that one's 30. This one's 82. And now let's measure the angle that we're interested in. Always getting it the wrong way. Alright. Oops, that one didn't measure very well. Or, I don't think it did. I measured something up here. I'm not sure what that is. I think that's just something that... Okay, so I'm going to move this back over here. Move this over here. And let's try this again. Okay, 2607. So now that we see what this angle is 26, I've got 30 degrees here. I got 80 degrees here. I don't really see anything other than, of course, as I change that, they're both kind of increasing. Alright, but that's not really what we want. We're hoping that there's some sort of an interesting pattern between them. So if I subtract, or if I add these, the 80 and the 28, I think it is, that's going to give me 100 and something, which isn't really close to 25, right? I mean, there's no way I'm going to get to that. Multiplying and dividing them doesn't make any sense. Let's see if we can make these just a little bit nicer numbers. I'm going to try with something with about like that. Okay, so this is like a 30, this is like a 83. We've got a 25 or 26 there. Still, it doesn't make any sense to multiply them or to divide them or even to add them, because this is now about 114, 115, and 26 doesn't have anything to do with that number. So the only logical thing to do would be maybe to try subtracting them and see if that makes any difference. Alright? Even though I see it's about 50, maybe I can find something with that. So that's what we're going to do. We're going to subtract these angles and see if that makes any difference, or if we can find something with this one down over here. Now remember, we're really comparing the arcs because the angles are equal to the arcs. I just can't measure those arcs in GeoGebra very conveniently. So we're going to go to View, and we're going to view some algebra. And I have a lot of stuff over here that I really don't need. So I'm going to click on this. I'm going to click on this segment thing because I really don't need that. I'm going to get rid of this internet thing here. And I'm going to click on this point because I really don't need that, nor the line. So I'm going to kind of condense things a little bit. I'm really interested in these angles, and you're looking at those angles going, what the heck, those funny characters? Well, those are Greek symbols, and that's how angles in GeoGebra are labeled. All right. Okay, so down here on the bottom, I have an input bar. Now, if you don't have an input bar, you can go to View and Input Bar and check it, and it'll show up. And that's, I want that input bar because I need it. And in yours, the commands for all these things would be over on the top right. You'll have 3 bars, and if you go down to View, it will show you how to do it. So you go to the top right, click on the 3 bars, go to View, and then you can find the algebra on the input bar and all of that. That's where yours is going to be. You're just using a little different version of GeoGebra. I think yours is actually newer. Mine's a little older. So what I want to do here is just go ahead and check this angle out. So I see that the one I want is 83.72, which corresponds with this little letter here. So I'm going to go to the side, and I'm going to click on that. And there's all my Greek letters. So I just want to get the one that corresponds with the 83. I think that's that one. Okay. Before I do that, I should arrow in front of that and put a parentheses. Alright, minus. Now what I want to do is check and see which one corresponds with the 31. Well, that's a funny looking symbol, but it's a Greek letter, alright. Let's see if we can find it. Oh, it's right next to the E. How convenient is that? Alright. So let's go ahead and subtract that. And we get 52.61. Now, is there a way to get from 52 to 26? Wait a second. I think we can divide that by 2. So if I take this, which you can see is another Greek symbol, so let's go get that. Let's see, which one is that? Oh, I think it is. Let's see if we can find it. I know it's right in front of me, but oh, there it is right there. And I'm going to divide that by 2. And press enter. And I'm going to drag this out and compare them. Look at that. They are the same. So now, if I take this point and I move this around, I can see that that is true, that always works. Okay? So these two arcs, if I find the difference of them and divide it by 2, I'm going to get this angle. Who would have ever thought that, right? But that's what it is. It works out. Kind of interesting. So let's wrap all this stuff up with secants, and now let's really take some notes. All right? So let's go back and let's get our notes out. We should pause this and wait till everybody gets their notes out. We're going to write here, let's see what color, let's go, I think we're working with this blue, and let's stick with it. So a secant is a line that intersects a circle in 2 points. Alright? So that's what a secant is. So I'm going to draw a picture of it here. There's a secant. Intersects in 2 points. It's a line. Alright? I can pause at any time. What about our secant properties? Okay, the first property was the one that we talked about up above there. But we're just going to redo this. There's our 2 secants. So we have a triangle and a triangle. And we thought they looked similar, and they were. We have this triangle here, which turns out to be similar to this triangle here. Alright? So, what that means is that AY multiplied with YK turns out to be the same as YC multiplied with YE. Alright? When we did the proportion, that's what we got. YA, or AY, doesn't matter, times YK equals YC times YE. Right? Secant to secant. Or secant properties. Okay, so what about this one? Well, in this case, we talked about the arcs, right? So I'm going to call this angle 1 right here. So angle 1 is equal to arc AW minus arc BE divided by 2. So it's going to take the measurement of this larger arc minus the measurement of the shorter arc divided by 2 is going to give you that angle right there at I. So those are our secant properties. There are other secant properties, but we're only interested in these 2. There's a couple other more kind of interesting ones, but again, we're just going to stick with these 2. So let's do a couple of examples of the secant properties that we're talking about here. So let's do this one here. I'm going to draw another secant. More secants. So let's say that this here is 8. Let's say that this here is 12. Let's say this distance from W to K is 10. And we want to figure out what this is. Here we'll put like a little X there. Actually, we want to figure out what IA is. The whole length. Okay? So, remember what we had. So we have AZ, that's 8, multiplied by this whole length, right, which is what we're trying to find, equals 12, multiplied, but here we need the whole length, not just, we need this whole length. So that's this 10 plus this 12, so that makes 22. Alright, so now I need 12 times 22. Let me get my calculator out. $264. And then divide that by 8. 33. So IA is 33. Now we could have made any part of this. Alright. We could have put an X here. We could have put an X on this side or this side or this side. Doesn't make any difference. We're just writing our proportions. Go ahead, and the cross multiply is already done for us. So we're taking this side here times this whole length here equal to this side here times this whole length here. Okay. It kind of makes sense when you look at the secants. Okay, let's do another one here. This time let's talk about the arcs. So let's say we make this one here 140. We'll make this one here 50. And we want to find that angle right there. Okay? So we know that that angle, called angle 1, is equal to 140 minus that arc there. So we're talking about arc to arc divided by 2. 140, so that's 90. Divided by 2, 45. Alright? This angle is equal to the difference of those two arcs cut in half. Let's do one more like that. Ooh, let's see if I can do a better circle. No, not bad. Okay. Okay. This time, I'm going to say that this arc here is 30. And I'm going to say that this whole thing here is 160. And I want to find the arc ET. Okay, here we go. So this time we have 30 is equal to 160 minus, we're not sure what that is, divided by 2. So, we simply just do this cross multiplication. Alright, and we can see that x has to be 100. Don't even have to do a whole lot of work there. We can see that's going to be 100. So there's our sector property, our secant properties. Alright, with those two, we're not quite done yet. Okay. So we have to do one more line here with circles. We're going to go back into GeoGebra. I don't need this drawing anymore, so I'm just going to go to File, and I'm just going to get a new window. And I don't want axes, and I don't want a grid, and I don't want the the algebra for right now. I'm going to make mine a little bit bigger so you guys can see it better. Okay. Circle. There it is. This time we're going to look at one other line that goes through, and we want it to be a line that touches a circle in just one point. So if we put a point on the circle, and I'm staying away from this point over here because that changes the size of the circle, and I don't want to mess with that. So now I'm just going to put a line through there. And this line looks like it touches a circle in one spot. But if I move it around, I see that really it's just a secant line. And that's no different than what we just did. So what we want to do is, let's get rid of that line. And we need to do something different. We want to make sure we can lock that line in place so that it can only touch the circle in one point. The way to do that is to draw a segment. And this segment we know represents, hopefully you said radius, because that's what it does. Now to get a line to go through that point right there and not go through any other points on the circle, we are going to do a perpendicular. So we're going to do a perpendicular line through this point perpendicular to this segment. Now when I do that, I now get this situation. And I cannot move this line any other place but right there. Right. So this line is called a tangent line. So tangent means that it is perpendicular to the radius and only touches the circle on one point. Alright, so that's a tangent line. Let's do the same thing. Let's go over here on this side of the circle and let's draw a radius and draw another tangent line. So remember, the important thing with tangent lines, gotta have a perpendicular or else it won't work. Perpendicular at that point, perpendicular to this segment. Okay, so once again, there's my tangent line. And of course we could say, hey, what do we notice? I don't know where this thing came from, but I'm gonna get rid of it. Okay. Alright, so here we go. Here's my tangent line. And we see that they cross. You know, of course, unless they're parallel, but they're going to cross. Doesn't appear like they'll ever cross inside a circle. They're always going to cross outside a circle. Unless they're, of course, they're the same tangent line. They have to be different. Alright. So, we notice that, right? Outside the circle. Let's see, we got a couple of 90-degree angles there. And like with the secants, where we had triangles, in this case we really don't have a triangle, but we could make one. Right? We could go like this, go down to here, and hopefully it'll just connect right there. Beautiful. I think that's going to work. Let me see. Oh yeah, okay. So now we do have two triangles. So obviously I'm going to say, hey, what do you think about those two triangles? What do you notice? Well, we know they're right triangles. Yep, for sure. You got right angles there and there. And last time the triangles are similar. So, okay, well, let's see, do we actually have similar triangles here? Well, we know we need two angles. Let's measure some angles and find out. So let's go from here to here to here, and let's measure this angle. And then let's do the exact same thing. Oops, look in the wrong direction. So, I got this 64.8, 64.8. I can move it, come on. Okay, so there we go. Sure enough, it looks as if those two angles are going to be the same. Alright, so you're probably now saying, hey, those triangles are similar, but you know what? Let's further investigate this. We know that this side and this side, those are radii. And a radius and a circle are always the same. So these two sides are the same. We also know that this side is the shared side between these two triangles. So none of these triangles similar. They're better than that. They're congruent. because we have a side, an angle, and a side. That's a little sass. So these triangles are congruent. And I say, oh, how about that? Okay, so that means these angles are congruent, right? Because all the parts are going to be congruent. But it also means that these two sides are congruent of the triangle. So when we have two tangent lines, all right, these distances from the intersection point to the point of tangency, that's what that's called, are equal. Okay, so that's a property of tangents. All right. So let's go make some notes about that. So first of all, we need to define what a tangent line is. So we know it's a line that's perpendicular. That's the key. Perpendicular to the radius. All right. Intersects a circle in one point. I'm just going to say that. So there's my circle. Here's my radius. And here's my tangent line. Okay. Now this point is called the point of tangency. Okay. Point of tangency. Now, some of you might be thinking about, well, wait a second now. Hey, we just did some stuff on tangent not too long ago with opposite over adjacent. And now it has to do something with a line and a circle. Well, in actuality, they're related. The construction to show that the word tangent, which actually opposite over adjacent, but it came from the idea of a tangent line to a circle. It's kind of a complicated construction to really go through that, so we're not going to, but it is there, and it is exactly related in that this whole opposite over adjacent thing came from a construction that had to deal with tangents and circles, and that's exactly where tangent came from. Okay. So a tangent is a line that is perpendicular to the radius, intersects a circle in one point. All right. So there's my point of tangency. Then we know we draw a radius, and I draw a point, a line, tangent line there, and a tangent line there. Okay. You know, then this. So let's put some things on here. Let's see. Okay. So here's what we know. Triangle WIL is congruent to triangle LIO. I need an O here. WI, not L, but this needs to be an O. It's congruent to triangle LIO. Right? And the most important thing is that WI is congruent to LI. So these two measurements here and here are the same. Okay. Maybe not the same in my drawing, but they are the same because we showed that. All right. So if we have, again, pause this. You need to do the tangents. That's the point tangency, and we know this distance here is 20. Then automatically that distance there is 20. They gotta be the same. Okay. There we go. So that's the whole story with tangents and secant. Hopefully you kind of got that. There will be an assignment for you. Don't forget, your project is due on Friday, and you'll have, you need to finish and turn in the one assignment that I gave you yesterday. Please make sure that you do the Google Classroom problem that was in there. There's 2 of them. Turn them in. If they don't turn in, then maybe Mr. Beater can sign off that you did them, and then we can go from there. So do this one here, and I guess that's it. I'll have a good day. See you on Friday.